Good morning. We're going to continue with Lewis dot structures, and this handout is going to give you several examples of Lewis dot structures. What I'd like you to do is have your handout available and also have a highlighter available as we go through some of these examples. First thing that I would like you to do is on that front page, highlight where it says example 1, then highlight where it says example 2, and then highlight where it says example 3. So that'll give us a little bit more organization on that front page. The next thing that I would like you to realize is that when in these examples, when they arrange the atoms, they technically do not arrange them in the skeletal structure. For instance, if I were originally organizing these atoms, I would have went ahead and drew my skeletal structure with the bonds in place. They arrange their atoms without the bonds in place. It's not right or wrong. It's my preference to write them with the bonds in place when we originally write out the atoms. So each of their original steps when they arrange the atoms, they do not include the bonds. I do include the bonds. So that's something that's a little bit different. You can see each one of these examples goes through 5 steps. 5 steps, just like in our notes. So I would have your notes available to you when you're going through these examples, because they will be very useful in explaining what's going on with each of the steps. Then please take a look at example number 2. Please highlight where it says boron is a special element and can have an incomplete octet. We haven't talked about this yet. Last time we were together, we talked about expanded octets, where atoms could have more than 8 valence electrons. Here, boron is an exception to the rule, and it has an incomplete octet. It only wants 6 electrons. There's one other atom, beryllium, that only wants 4 valence electrons, and that is also an incomplete octet. Boron and beryllium are the two that we'll be dealing with that have incomplete octets. So there's 3 examples on this front side of step 1 through 5, step 1 through 5, and step 1 through 5, where they get to the final structure, the final Lewis dot structure. If you flip your page over to the next page, there are 3 more examples on this page. So the first one is example 4. We'll highlight example 4. The second one is example 5. We'll highlight example 5. And then the last one says example 3 again, and that's a typo. We're going to change that and make it example 6 because it's the 6th example. On this page, once again, each one of the examples has 5 steps, but there's 2 important pieces that I need to point out. The first is that this is a polyatomic ion, an NH4 with a positive. Because of that positive, that means this molecule does not have as many electrons as it might typically have. So take a look. Here, because of the plus, that means it has 1 less electron than what it would typically have. So I want you to highlight where it says, note that we subtract 1 electron from the total because NH4 plus has a 1 plus charge. So when they add up the electrons, they put a 1 minus here for the total. Now let's take a look at example 6. Example 6 is NO2 with a 1 minus. That 1 minus means that this molecule, NO2, brings on 1 extra electron in order to get that 1 minus. So in this case, we have to add the extra electron because of the 1 minus charge. So here, they put a plus 1 here in order to get 18 total electrons. So once again, 3 more examples. This one we previously did in our notes. If you look, Example 5 is a new example. Example 6 is a new example. So each one of these, they're going through 5 steps in order to get the final Lewis structure. The final Lewis structure for example 6 is on this next page. We're going to save resonance for next time, but please highlight where it says expanded octets. Expanded octets we actually covered last class in 2 of our examples that we did in your notes. If you look back at those examples, one with Xe xenon and one with Sb antimony, both of those examples dealt with expanded octets. Expanded octets is a fancy word for the central atom has more than 8 valence electrons around it. So when you're all done, that central atom ends up having more than 8 valence electrons. And there's an example here. Please highlight where it says example 7. That's an expanded octet. And then on the next page, please highlight where it says example 8. That is also an expanded octet. And then we also have another typo. Instead of example 8, this should say example 9. And be very careful. This says SBF5, but if you count the F's, there are really 6 F's around the SB. So we also have to put an SB here because I just had an S here, SB here because it just showed an S, and SB here because it just showed an S. But then, more importantly, we got to change that 5 to a 6 because there's 6 SBs. So this is 2 more examples where the central atom gets more than 8 valence electrons. We call that an expanded octet. The final 2 pages we're going to save until we get back from Christmas break looking at the geometries of the molecules. But this gives you another several examples, 9 examples with those 5 steps in them on how to make Lewis structures. Finally, today we're also going to be covering the worksheet Lewis Structures 1. Each one of these names I have placed on the front board. And for each one of the names in blue, I have placed the skeletal structure, step 1 for that specific molecule. For question 1, the hydrogen cyanide, I actually worked out the complete example on the front board for you. Step 1, making the skeletal structure. Step 2, adding up the valence electrons. Step 3, subtracting away the skeletal electrons. Step 4, adding in the valence electrons, and then step 5, checking on that central atom. The other examples, I've only wrote out the blue skeletal structures on the front board. So I'm wanting you to go through steps 2 through 5 to find out how to come up with those Lewis structures. And then we'll review these Lewis structures on Wednesday when we return. If you have any questions, you may email me as well. I hope everything goes well.